7.6 is renaming fractions and mixed numbers. What we're really doing is just going back and forth and changing mixed numbers to improper fractions and improper fractions to mixed numbers. So a mixed number is going to be a whole number and a fraction. So you can see here 2 3/7 is a great example. We've got a whole number or a big number. We've got that fraction piece as well. Improper fractions, sometimes called top-heavy fractions. The book a lot of times will call them fractions greater than 1. Gonna look like this, where our numerator is bigger than our denominator. So it's worth remember that if our denominator was thirds, 1 whole would be 3/3. So 7/3 is going to be greater than that. Anything where that top is heavier, bigger than our bottom. So if we have a fraction like 1 3/5, I could draw out 1 whole piece, and then 1/5, 1/5, 1/5. And I have 1 3/5. But maybe I'm having a party. I want everyone to get 1 piece. And right now I can only share with 4 people or give to 4 people. And one person's going to get a way bigger piece than everyone else. So we want to think, is there a way that I could maybe give everyone the same size piece? So we're going to want to think, okay, what does 1 whole become? I'm not going to, these unit fractions, I'm not going to do anything to them. But 1, I could make this into fifths, since the rest is already in fifths. 1/5, 1/5, 1/5. I'll try and line these up. 1/5 and 1/5. I know those aren't perfectly equal, but we get the idea behind it. So now I could say, okay, how many fifth size pieces do I have? 1, 2, 3, 4, 5, 6, 7, 8 fifths. So 1 3/5 becomes 8/5. The other way we could look at it is 1 3/5. That'd be like 5/5 plus 3/5. Then we just add across, and that gets us 8/5. Our trick with mixed numbers and converting them into improper fractions is you're going to go up and multiply and go over and add. So 1 times 5, because that's going to get us that 5/5. 1 times 5 is 5, plus 3 is 8, so that makes it 8/5. That's sort of the trick we learn after we've nailed down this. So then let's look at some more examples, some larger mixed numbers. We might get something like 3 1/6. So I could draw out all of those model pieces. That's going to take me a long time. I could say that 3 1/6 is like 1 plus 1 plus 1 plus 1/6. All these ones we know would be 6/6 plus 6/6 plus 6/6 plus 1/6. Now I just add across. If we think back to learning multiplication, multiplication is just repeated addition. So how many times did I add 6? 3 times. This is where that multiplying up, 6 times 3, or 6, I did this 3 times. So that got me 18/6. Plus my 1/6, and that's where that adding comes in, gets me 19/6. Sometimes, very rarely, it will ask you to put in simplest form. I'm not necessarily going to require that, though. I'm just looking that they're able to take a mixed number and put it into an improper fraction, and an improper fraction into a mixed number. So let's look at that now. So again, multiply up and then over, or break this up. This is another great strategy. And add across. Either way works. So now let's say we have an improper fraction. We have something like, let's do what I had originally done, 7/3. So I know that I need to equal 7 and that this is going to be greater than 1. We can think back to adding fractions and writing it as a sum. I could think, okay, my denominator is going to be thirds. What could I do that would get me 7/3? Now I'm going to want to stay, the biggest I go is a whole at a time. So I'm going to do 3/3 plus 3/3. I know 3 plus 3 would get me 6. How much more do I need to get to that 7? I need 1. Now I'm going to say, okay, That's a whole, that's a whole, that's going to stay a fraction piece. So 1 plus 1 plus 1/3 gets me 2 and 1/3. Super easy way to check this is multiply it and add back. 3 times 2 is 6. 6 plus 1 equals that 7/3, and that's what I got here. Other way we look at it is knowing our division facts. So 7 divided by 3 is 2. 2 times 3 is 6. I have 1 left over. That's going to become my numerator. My 3 stays my denominator. Get the same thing. This is why your basic facts are going to be so important. We're going to use them for everything we do. Let's look at one more example. So we'll do 4 and, let's do 47. Let's do 47/6. So I could stay here and do 6/6 plus 6/6 plus 6/6 until I got close to 47, or I could just divide. So, or think how many times, 6 times what gets me 47 or close to it. So I'm going to say I know that 6 times 8 gets me 48, so that's going to be too much. I know 6 times 7 gets me 42. So I'm going to do that. Subtract, I get 5. My remainder becomes my numerator. My denominator is what I divided by. So I got 7 and 5/6. Easy way to check it. Convert it back. 7 times 6 is 42. 42 plus 5 is 47. That's the answer I originally got. So 7 and 5/6 will work.